Section 5.4, Day 1, is on properties of trapezoids and kites. Today we are going to focus on the trapezoids, and then the next lesson will be on the kites. So our objectives today are to identify the characteristics of trapezoids, use properties of specialized quadrilaterals to complete proofs, and we're going to classify quadrilaterals with the most specific name again. To start off with, we're going to define a trapezoid. This image below is what a trapezoid could look like, and what characterizes it as a trapezoid is it has exactly one pair of parallel lines, and the non-parallel sides are called the legs, and the adjacent sides to the adjacent angles on the same base are called pair of base angles. So these two angles down here, these are called the pair of base angles. So those two right there. And then we also have a pair of base angles on top. So we have two sets of pair of base angles. So last time we talked about quadrilaterals. We had parallelograms, which can be broken down into rhombuses, and ran out of space. These are all such long words. And rectangles, which are both a type of square, or can be a square. So today we're adding on a new branch, which is trapezoids. And trapezoids are different than parallelograms because they only have one pair of parallel lines, where parallelograms have two pairs. Okay, so we have some theorems working with trapezoids, and if a trapezoid is isosceles, then each pair of base angles are congruent to each other. Then if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. And a trapezoid is isosceles if and only if its diagonals are congruent. And there we go. So we are going to use these three theorems with our trapezoids. Example 1. A shelf fitting into a cupboard in a corner of a kitchen is an isosceles trapezoid. Find the measure of angle N and the measure of angle L and M. So this is an isosceles trapezoid, so we know this pair of base angles are congruent to each other, which tells us that the measure of angle N is also equal to 50 degrees. And because this is a trapezoid and we have this one pair of parallel lines, we know that these same side interior angles are going to be supplementary, which tells us the measure of angle K plus the measure of angle L is going to be equal to 180 degrees. We already know that the measure of angle K is 50, so what we are left to find is the measure of angle L. And we can do that by just subtracting 50 on both sides. And we find that the measure of angle L is equal to 130 degrees. And because this is isosceles, the measure of angle M M is also going to be 130 degrees, which is the last part of our problem. So now we have found all 3 angle measurements that we were asked to. Example 2. Find the measure of angle C, the measure of angle A, and the measure of angle D in the trapezoid shown below. We are given angle B. To find angle A, we can take 180 and subtract 135 because we know those 2 angles are supplementary to each other, which will leave us with 45 degrees for that base angle. And we do know that these legs are congruent to each other, just like our last example, which tells us this is going to be isosceles, leading us to conclude that our other base angle is 45, and this angle on the bottom is 135. And if we just rewrite all these over here, we are good to go on this problem. And that's our answer. All right. Next we have the mid-segment theorem for trapezoids. The mid-segment of a trapezoid is parallel to each base. So all 3 of these lines in this trapezoid are parallel with each other. And its leg is 1/2 of the sum of the lengths of the bases. And that means if our base on top was 6 and the base on the bottom was, let's say, 12, we can find the length of MN by adding those 2 base lengths together, so 6 plus 12, and dividing by 2. And that will tell us what the length of MN is. So 6 plus 12 is 18. 18 divided by 2 is 9. So that's just a brief example of how we can use that to find the length of the mid-segment of the trapezoid. So use that example and go ahead, pause the video to complete number 3. Once you have your answer, you can hit play and see if you got it right. So when you did this problem, you should have added 16 plus 9 to divide it by 2, and that's going to be the length of our mid-segment MN. And this would give us 25 over 2. You'll notice we will get a decimal answer, and that is okay. And it should have been 12.5 inches for our final answer. Okay. And again, if you didn't get that one right, try pausing it and then do the next one on your own to see if you can do this one. So again, we're finding the mid-segment MN, and it doesn't matter if our trapezoid is turned sideways. These are still our bases because they are the lines that are parallel to each other. So to find MN, we would have added 30 plus 12 all over 2, which would give us 42 divided by 2. And our final answer would be 21 feet. And that is what we would do for the mid-segment theorem. The last thing we are going to do is we are going to complete a proof. And we're just doing these one at a time and to get some practice in, and we'll focus more on these later. So in this proof, we are given that ABCD is a parallelogram with a diagonal AC. So we're just going to write all of that down in our given information. Great. Once you have your given information, then we're going to take a look at what we are trying to prove. In this one, we're trying to prove that triangle ABC is congruent to triangle CDA. If you don't remember, we have our 5 different ways of proving triangles are congruent. We have side, 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 angle, angle, side, angle, 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 side, and we also have hypotenuse, leg. For this one, we can't use hypotenuse, leg because we don't have right triangles. So to figure out which one we're going to use, we're first going to start finding information. And there's multiple different ways you could do this problem to prove that these 2 triangles are congruent. The way that I'm going to choose is because I like the reflexive property. I'm going to say AC is congruent to AC. And that is the reflexive property of congruence. So we've already proved that that one side is congruent. We were told that ABCD is a parallelogram. And if you remember, parallelograms have opposite sides congruent to each other. So we can go ahead and say that the other sides of the triangle are also congruent. We know AB is congruent to CD. We also know BC is congruent to AD. And from our last lesson, we talked about how we would write our reasons for this. And if we have a parallelogram, so we're going to start with the parallelogram, that implies that opposite sides are congruent. And that is how we would write the reason for this one. And now we have already shown that all 3 sides are congruent between the 2 triangles, and we can use the reason side, side, side to say that triangle ABC is congruent to triangle CDA. And our reason would be side, side, side of congruent triangles. So that is our last example today for this. If you have any questions, please let me know. We do have a second quiz tomorrow for the chapter on 5.1 to 5.3. You are going to end up doing this exit ticket before you start the homework, and then you are good to go. Let me know if you have any questions, and don't forget to check your answers on your homework.